Hello guys, welcome to Head First Design Pattern Chapter 2. My name is Lucky. In this chapter we'll be discussing about observer pattern. So let's start. To understand the observer pattern, we'll take an example of weather station. So what the problem statement is like, we have a weather station who is measuring humidity, temperature and pressure. What we need to do over here is like we need to have implement a weather data class which basically gets the latest measurement data and displays to the screen. The display screens are three. We have three display screen, which I'll tell you later. So if you unpack the weather data class, you will see we are provided a getter methods for all the three measurements, get temperature, get humidity and get pressure. We have a measurement change class, which if you read the comment provided, it says like this method gets called whenever a weather measurement have been updated. So we actually don't need to pull the data every time. So a weather station actually pushes the data to us and we just need to capture it. Okay, so what we know so far is like weather data class has a getter method for all the three measurements: temperature, humidity and pressure. And the measurement change class is actually called whenever there is a new measurement data is available. So if you remember, I told you like we need to implement three measurements. So these three display elements are uh, current condition display, statistic display and forecast display. This display must be updated each time weather data class is a new measurement. And last but not the least, the system must be expandable. That means like the other developer can use our uh, weather weather data class to add their own custom displays. Okay, so uh, here Joy, who is our developer, we provided this input to him, so he come up with an idea and he solved this problem using this solution. So if you see what Joy has done, he is getting the latest temperature inside measurement changed, and he is manually updating the current conditions to all the three display elements. What do you think about this design? Please write in the comment. So if you remember from the chapter 1, we have learned few design principles. So which says like encapsulate what varies, and by this we basically means like we need to extract out the code which basically needs the change every single time. Favor composition over inheritance, basically as self-explanatory, we need to use uh, composition over an inheritance. And program to an interface, not implementation. You can get this more understanding from my previous chapter 1 lecture. So if you see what Joy has done and where it actually not correct is like he is have these three elements, three display objects where he is like manually calling the update method to update the display. So in the event when we want to add a new display, we need to update this part, like the measurement changed with the new display. So we actually need to extract out this dependency. So as you know, like we are in observer pattern chapter, so you must be thinking like now it's time for observer pattern to come up and show its power. But before actually jumping into what observer pattern actually is, let's try to understand by an example. So you know how the newspaper and or magazine subscription works, right? A newspaper publisher goes into a business and begin publishing newspapers. You subscribe to a particular publisher, and every time there is a new edition, it gets delivered to you. As long as you remain a subscriber, you get a new newspapers. You unsubscribe when you don't want paper anymore, and they stop being delivered. While the publishers remain in business, people, hotel, airline, and other business constantly subscribe and unsubscribe to the newspaper. So you can say the pub sub model is our observer pattern. So in to understand better, let's take an analogy of an object, subject, and observer. So consider we have this subject who is streaming very cool integer values, and there are some subscriber objects who is listening to these values. Currently our subscriber pool consists of dog object, cat object, and mouse object, and there is a new duck object who wants to be a part of an observer. So duck object comes in and asks subject to make him as one of his observer. And now the subject has acknowledged his request and add this duck object into the observer pool. So now as soon as the object streams a new integer value, it gets automatically delivered to all the observers. Now consider there is a mouse object who wants to leave the observer. He wants to basically unsubscribe the object. So subject acknowledge its request and remove him from the observer pool, and subject object started streaming a new integer value. So it gets delivered to all the objects which are still a part of observer pool, except mouse who no longer be a part of observer. So now as you have seen the observer pattern in practice, it's easier for you to understand the definition. The observer pattern defines a one-to-many relationship between objects so that when object changes its state, all of its dependents are notified and updated automatically. So in this case, the observers don't have to manually pull the data from the subject. Subject is responsible for updating its latest states to all its observers. Now let's try to understand the observer pattern via class diagram. So in this, as I mentioned, like we have two interfaces, subject and observer. Subject interface has three methods: register observer, remove observer, and notify observer. Register observer is used to register a new observer. Remove observer is used to remove the observer at any point in time. Uh, Notify observer is actually gets called whenever there is a change we want to notify to our observers. Similar to subject, there is in the object observer there is a update method which uh, which gets called when there is a when subject wants to notify observer. So if you see what is basically happening, we are making a loosely coupled system over here. So by loosely coupled system basically means like we can add the observer anytime in, and we can unsubscribe the uh, subject anytime. So we are not tightly bound with the subject as we were doing in the initial design. So we arrived to our four design principle with this, which says strive for loosely coupled design between objects that interacts. So by loosely coupled design, you can design a system with the more scalability, because you are no longer tightly bound to any particular object. Coming to weather data station, here is an implementation via observer pattern. So the weather data class is now implementing the subject with register observer, remove observer, and notify observer, along with its all three methods which were there before. Here you see we have one more interface display element. So if you see, we have these three displays: current condition, statistics display, and forecast. Along with this, there is a third party display also we have introduced. Coming to the coding, how this is solving the problem is like, in the weather data class we have an array list of observers. So whenever there is an object wants to be registered as an observer, it calls the register observer class, and this new observer is added to the array list pool. If the object wants to, let's say, remove or unsubscribe from the from the weather data class, it can basically calls the remove observer, and the observer is removed from the array list. Coming to the notify observers, here is an interesting thing. So what is happening here is like, we are looping over the array list, the pool of our observers, and calling the update method. So as we are aware, like, the measurement changed class is actually called every single time when there is a new measurement. uh, so inside this measurement change class, we are calling our notify observers. So all the observers are getting updated dynamically as and when there is a new data available. Coming to the display part, how we have implemented this, here you can see it implements the observer and display elements, and there is this private subject weather data class, weather data reference, which is used to register an object as an observer. So here you can see in the constructor, the weather data object is getting used to register the current uh, display display object as an observer. And you can also see the update method, how it's implemented. So yeah, this is pretty much all about the design pattern, observer design pattern. I hope you like this video. Please uh, like, share, and subscribe to show your support. Thanks for watching.